Hello everyone. This presentation gives an introduction to concrete mix design, which is one of the most important concepts in concrete technology. Concrete mix design is the process of selecting suitable ingredients of concrete and finding their relative proportions, correct proportions, so that the concrete achieves required strength, workability, durability, and economy. In simple terms, it answers the question how much cement, sand, aggregate, water, and admixtures are required to produce 1 meter cube of quality concrete. Concrete is made up of four basic materials. The first is cement, which act as a binding material. Second is fine and coarse aggregates, which form the bulk of the concrete and provide strength and stability. Third is water, which reacts with cement through hydration and helps in hardening. Finally, admixtures. They are added to improve properties such as workability, setting time, or durability. The main objective of mix design is to produce concrete that satisfy the four important requirements. First one is strength, which means concrete should achieve the specified compressive strength after 28 days. Second is workability. Fresh concrete can be easily mixed, transported, placed, compacted, and finished. Third is durability, enabling the concrete to resist weathering, chemical attack, and abrasion throughout its service life. Finally, the mix should be economical, using the optimum quantity of materials without compromising quality. Several factors influence concrete mix design. Grade of concrete determines the target strength. The water cement ratio is one of the most critical factors because it directly affects both strength and durability. The properties of aggregates, including their size, shape, grading, and surface texture, influences the mix. In addition, the required workability, environmental exposure conditions, and the level of quality control at the construction site all play an important role in deciding the final proportion. These are the constituent materials in concrete: cement, fine aggregate, that is sand, coarse aggregate, water, and admixtures. Cement acts as a binder and it reacts with water to form the hardened matrix that binds all particles together. Fine aggregate fills voids between coarse particles and improves cohesion and finish of the mix. Coarse aggregate provides bulk, volume, and dimensional stability, the size chosen per member and cover. Water and admixtures. Water drives hydration, admixture adjusts setting time, workability, or durability. Water cement ratio is an important factor to be considered in the design of a concrete mix. According to Abraham's law, for a given set of materials, the strength of well compacted concrete mainly depends on water cement ratio. A lower ratio generally produces higher strength and better durability, but it also reduces workability. Therefore, we must be very careful in balancing the strength and ease of placement when selecting the appropriate ratio. The graph given here shows approximately the strength and water cement ratio. It is an illustrative example of strength and water cement ratio. The strength is high at lower water cement ratio and low at higher water cement ratio. Workability of fresh concrete. So it is very important. Workability describes how easily a fresh concrete can be mixed, transported, placed, compacted, and finished without segregation. It is most commonly measured on site using slump test. Key factors influencing workability are water content, the amount of water we are adding to the concrete, aggregate shape and grading, admixtures used, and ambient temperature during the time of mixing of concrete. The typical slump range for a nominal structural work is given here as 25 to 100 mm as per IS code. Concrete mixes are broadly classified into nominal mix and design mix. A nominal mix uses fixed proportions such as 1:2:4 and is suitable for small non-critical works. On the other hand, design mix is prepared based on laboratory testing of materials to achieve a specific strength and workability. Design mixes are more reliable, economical, and are generally used for major structural works, especially for concrete grades M25 and above. Nominal mixes given in the table are indicative only. For grades M25 and above, we should always use a laboratory designed mix as per code. To conclude, concrete mix design is the foundation of producing quality concrete. A good mix design ensures right balance between strength, workability, durability, and economy. It also highlights the importance of maintaining appropriate water cement ratio and selecting materials carefully. Understanding concrete mix design will help us to produce safe, durable, and cost effective concrete structures. Thank you.